So they ask you to find the exact value of I to the power of I. Yeah. So for anything with multiplication, with division, or with power, we just prefer to use polar form, which is r cis theta, or Euler form, which is r e to the power of I theta. Okay. Yeah. So for both of this, r is the modulus of that complex number, theta is the angle. Okay. Yeah, so I just do this conversion. So convert I into polar or Euler form first. So remember the diagram we always draw. This is 0 degree, pi over 2 degree, and pi, and minus pi over 2. And then the corresponding complex number, this is 1, this is I, this is minus 1, and the last one is minus I. Okay, yeah. So from this diagram, you can quickly convert these four super common complex numbers into their polar form. Yeah, so 0 equals to e to the power of 0. Okay, sorry, 1 equals to e to the power of 0, which is cis 0. Okay, and then I equals to e to the power of pi over 2, which is cis pi over 2. And then minus 1 equals to e to the power of pi, which is cis pi. And then last one, minus I, which is e to the power of minus pi over 2, or cis minus pi over 2. Yeah, so those four polar and Euler form and Cartesian form conversion should be really quick. Yeah, so we have I to the power of I. We convert this little I first. Okay, so convert this little I into e to the power of pi over 2I. Oh, sorry, I forgot to label I here. Yeah, e to the power of pi over 2I, and then all to the power of I, yeah, which is e to the power of pi over 2. I multiplied by I squared, just minus 1. Right? Yeah. So minus 1 multiplied by pi over 2, it's just e to the power of minus pi over 2. So you can see it's just e to the power of minus 1.7 something something. It's just a number. Okay, this is a pure real number. Okay, this is a pure real number. And then they ask you what are the restrictions on z to the power of I for it to be pure real. Okay. Yeah. So z to the power of I. So z is any complex number, right? We can just say z is r e I theta. Okay, all to the power of I. Okay. And then this should just become r to the power of I, e to the power of I squared become minus 1, so minus theta. Yeah, so this part, you can make sure it is always pure real. Okay. So real multiplied by pure real would be a pure real. So you need to make sure I r to the power of I equals to pure real. Okay. So you need to make sure this part is also pure real. Yeah. So how would you make sure r to the power of I is a pure real? R just have to equals to 1, right? R have to equals to 1. Because when R equals to 1, 1 to the power of anything is always 1. Yeah. So the restrictions on z to the power of I for it to be a pure real, so the restriction is just R equals to 1, or the modulus of R equals to 1. Okay, so these are the restrictions. Okay, so what kind of z to the power of I would be a pure real if z lies on the unit circle? Yeah. So if you have a z lies on unit circle, then z to the power of I would be a pure real number.